Alright, so now what we're going to do is an example for how to write a chemical equation. Okay, so here we've been told about a reaction that occurs between sodium carbonate and aluminium chloride. Okay, and we've been told that it produces solid aluminium carbonate and sodium chloride solution. Okay, so we've been given the reactants here. Okay, now the first thing that we have to do is work out the chemical formulae for the products. So here we have aluminium carbonate. So we know that aluminium carbonate here, because the chlorine ion involved here is, we know that chloride ions are minus ions, and because there's three of them and we have an aluminium ion, we know the aluminium ion must therefore have a charge of 3 plus, because the 1 to 3 ratio means that if aluminium has a 3 plus, the chloride ion, then having 3 chloride ions will balance it out. Now usually you will know the charge that a given metal takes when it is in ion form. However, in this case, aluminium is one of the special metals that has two possibilities for the charge it can take in ion form. Okay, so most metals you should be able to know, okay, we have, you know, a magnesium ion, not a magnesium ion. But most metals, we should say, for sodium, for example, if we look at sodium ion, we see a sodium, we're told it's an ion, we know that sodium ions always have a charge of 1 plus. Okay, aluminium is not the case. Aluminium is not one of the metals where we know the charge that it can take. Okay, aluminium is one that can take a charge of 3 plus or a charge of 2 plus. Okay, but in this case we've worked out the formula, we've worked out that this is the one that we are after. Okay, so therefore up here, this is the formula of the products. Okay, so we know that the aluminium ion is Al3 plus. Okay, we know that the carbonate ion is 2 minus. So we know from off the top of our heads that the carbonate ion has a charge of 2 minus. We should know that. However, we can look here and work it out. There are two sodium charges, each with 1 plus charge. So therefore, the carbonate ion must have a 2 minus charge for the charge balance. Okay, so we've worked that out. Now sodium, we know Na plus. Okay, chloride, obviously Cl minus. Okay, so we've worked out the formula for each of the ions, for each of the ions. So now what we have to do is put them into ionic formula. Okay, so we have solid aluminium carbonate here. We've got a 3 plus charge and a 2 minus charge. So that means the ratio of aluminium to chloride is going to be 2 to 3, as 2 aluminium charges will have a total charge of plus 6. 3 carbonate charges. So here, this should be a carbonate. So we know that in the product, we're producing carbonate. Okay, so we know that the ratio between the aluminium 3 plus and the carbonate 2 minus is going to be 2 to 3. Okay, and this is because 2 aluminium charges will have a total charge of plus 6. 3 carbonate ions will have a total charge of minus 6, and so they will cancel. Okay, so the formula is going to be this. Okay, and so because this carbonate ion here, it has multiple elements in it. It's not just one metal sort of ion. It's got three different atoms, kind of constituent atoms forming it. Okay, and so what we need to do, rather than so we need to section this off. So this is one ion. Okay, and we have 3 of them. So we have to do that with all of the ions that are made up of multiple atoms. Okay, any ion that's made up of multiple atoms needs to be bracketed off when you're sort of multiplying it here with this 3. Right, so we know the formula for the aluminium carbonate is Al2CO3. Okay, we know that the sodium chloride, 1 plus charge, 1 minus charge, 1 to 1 ratio is going to be NaCl. Okay, so we know that, and we've got our reactants over here. So we write out our equation. Alright, so we've got there's our reactions, and we know that they are producing these two. So aluminium carbonate and sodium chloride. Alright, so now we've got our ionic formula. We've done the first step. So now the next thing that we have to do is balance the chemical equation. Okay, so here the first thing we look at, okay, if we look at sodium, we've got two sodiums here, none there, one sodium here. Okay, so first looking at this, it looks like we're going to need a 2 there. Okay, but now the problem we have is we have 2 chloride ions here and 3 chloride ions here. Okay, so we know that is not going to work. Okay, so it takes a bit of trial and error sometimes when we're balancing equations. Okay, so instead what we're going to do is we're going to look at another item. We're going to look at carbonate. Now carbonate is the one that is multiplied by the most. Okay, this number 3 here, it's the ion that's multiplied by the greatest number, same as chloride. Okay, we're going to look at carbonate first. So we've got 3 carbonate ions here, so we're going to put 3 over here. So now both sides have 3 carbonate ions. Okay, so now if we look on the left hand side, we have 6 sodium ions. Okay, so therefore we've only got 1 here, so multiply this by 6 as well. Okay, so now the effect of this change is that we now have 6 chloride ions on this side. So we need to put a 2 here. At the moment we've got 3 chloride ions, so we need to double this amount to make it 6. So we put a 2 here. Okay, and then fortunately we now have 2 aluminium ions. We need to make sure we check this last ion now. So we've got 2 aluminium ions and we've got a 2 here. So that works. Now for me, I find that as I sort of mentioned earlier, that the best way to do this, the best way to sort of avoid the trial and error and the mistakes, we have to rub out your mistakes, is to look for the ion with the largest multiplying factor. So here we have, which is multiplied by number 3, okay, and that is bigger than any other. Yes, chloride is also, alternatively, we could have used chloride first, okay, and this would have also achieved a successful result, although slightly slower again. Okay, but as a general rule, it's best to look for these items with the largest multiplying factors and start with those, and you'll be able to reduce the number of errors and sort of number of errors that you have to cross out, or mistakes you have to rub out with your rubber. Okay, so yes, here if we'd used chloride first, we would have had a 3 here instead of a 6, and we would have sort of had to rub that out later and double it to 6. But here we used carbonate, and we got right to the first answer. So yes, sometimes using the largest multiplier does not get you straight to the answer, but it's often a slightly more effective means of getting there. Okay, so now what we've done is we've balanced the equation, and so now these are the two things that are often forgotten. We all analyze the reactions happening, work out the chemical formula, write the equation, but we always forget to balance. Okay, so now what we've done, we check to see if it's balanced, and we check to see if we've done states. Okay, now in this equation, the states are pretty easy. Okay, they've all been given to us, and usually there's not so much calculations involved, but just analyzing the data we're presented with, or looking for those keywords as I discussed, to look for the state of a particular. We've balanced the equation, so now all we have to do is fill in the states. Okay, so we've been given the 2 reactants up here in their chemical form, so that's pretty easy. We can just write that in here and here. Okay, now we've been told in the question that the aluminium carbonate that's produced is solid. That's fine. And we've been told sodium chloride solution. Okay, so we look for that keyword solution. That means it is aqueous. So now we put that in. We've done our state. So we've sorted both of these 2 issues out. These are both very crucial. Okay, these are kind of your checklists that you can do when you do a chemical equation, and they're very easy to forget. So we've done both of these, so this is our final chemical equation.